to solve finite series using some terms in finite sequence. Always remember the general formula in getting the series of a finite sequence is represented by S sub n, which is equal to a sub 1 plus a sub 2 plus a sub 3 plus and so on and so forth until we reach a sub n. So let's try an example of a finite sequence. The terms here are 8, 16, 24, and 32. So we are to find the series of these four terms. Before going with the solving part, let's identify the values of each term. So a sub 1 is equal to 8, a sub 2 is equal to 16, a sub 3 is equal to 24, and a sub 4 is equal to 32. Now that we already know the values of our terms, let's write the general formula for this sequence. So the formula for this sequence is a sub 4 is equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Why is it a sub 4 only? Because we are only given 4 terms in this sequence. Using this formula, let us substitute the values of our terms. So once we have substituted, this is the form. S sub 4 is equal to 8 plus 16 plus 24 plus 32. Once we have this one, add all the terms so that we can have the value of our series. So once we have added 8 by 16 plus 24 and 32, we will have the sum of 80. Meaning to say the series of these 4 terms is equal to 80. Another example, let's try to have a finite sequence that have a term of 2, 4, 6, 8, 10, and 12. So we are to find the series of these 6 terms. Before that, let's identify first what are the values of the term. So a sub 1 is equal to 2, a sub 2 is equal to 4, a sub 3 is 6, a sub 4 is 8, a sub 5 is 10, and then a sub 6 is 12. Now that we already have the values of our term, let's write the general formula for this sequence. So this is represented by S sub 6 is equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 and a sub 6. So after writing the general formula of this sequence, let's substitute the values of our terms in each term. So it will look like this. S sub 6 is equal to 2 plus 4 plus 6 plus 8 plus 10 and plus 12. When we add all these terms, we will get 42. Meaning to say, the series of this sequence is equal to 42.